For years, technology companies have been trying to make digital humans look more realistic. First, we had profile pictures, then came beauty filters, face-swapping apps, virtual avatars, and AI-generated presenters. Now, we are entering a new stage, three-dimensional facial reconstruction. Instead of working with a flat photograph, the system attempts to rebuild the actual structure of a person's face. It estimates the shape of the forehead, the depth of the eyes, the curve of the nose, the movement of the lips, and even the way light falls across the skin. The result can be rotated, animated, relit, and placed inside almost any virtual environment. Technically, this is impressive, but the real question is not whether a computer can reconstruct a convincing face. The real question is whether people will trust it. Because right now, AI-generated humans are stuck in a strange position. They often look realistic enough to attract attention, but not always realistic enough to feel completely safe. You might watch an AI presenter and think, "This looks almost human." And that word "almost" is exactly where the problem begins. A slightly unnatural blink, a stiff cheek movement, teeth that look too perfect, or eyes that do not quite focus correctly can immediately create discomfort. Even when viewers cannot explain what is wrong, they can often feel that something is wrong. Three-dimensional facial reconstruction promises to fix many of these problems. But can it really cross the final barrier of user trust? I think it can help, but realism alone will not be enough. To understand why, we first need to look at what 3D facial reconstruction actually changes. Most traditional face generation systems mainly operate on two-dimensional images. They generate a new frame based on the previous frame, trying to maintain the same identity, lighting, expression, and viewing angle that works surprisingly well when the face stays mostly still. But once the person turns their head, moves closer to the camera, changes expression, or enters different lighting, small inconsistencies can appear. The ears may change shape, the nose may become slightly narrower, the distance between the eyes may shift, shadows may move in ways that do not match the geometry of the face. A human viewer may not consciously notice every inconsistency, but the brain is extremely sensitive to faces. We spend our entire lives reading tiny facial signals. We notice tension around the mouth, changes in the eyebrows, eye contact, hesitation, and emotional reactions. So even a small error can make a digital person feel artificial. 3. Dimensional reconstruction gives the system a more stable foundation. Instead of constantly guessing what a face should look like from every angle, the computer has an underlying model of the face. Think of it like building a digital mask, except the mask is not static. It can move with facial muscles, follow speech, react to lighting, and maintain the same proportions from different camera angles. This can make digital humans much more consistent. A person can turn their head without their identity changing. Lighting can move naturally across the face. Expressions can be generated based on the actual structure of the cheeks, lips, and jaw. That consistency matters because trust is partly built through predictability. When a face behaves the way we expect a real face to behave, we stop studying the technology and start paying attention to the person or the message. And this is where 3D facial reconstruction could become extremely valuable. Imagine an online shopping experience where you can see exactly how a pair of glasses fits your face, not just as a flat filter, but from different angles. Imagine attending a virtual meeting where your avatar reproduces your natural expressions without requiring you to keep a camera pointed at your face. Imagine a patient speaking with a digital medical assistant whose expressions feel calm, responsive, and emotionally appropriate. Imagine a language learning system where the virtual teacher can clearly demonstrate the exact movement of the lips and tongue. In all of these situations, a more accurate digital face can improve communication. But there is another side to this technology. The same system that can reconstruct your face for a useful virtual experience can also create a highly controllable digital version of you. And that is where trust becomes much more complicated. A photograph captures one moment. A 3D facial model captures something closer to an identity asset. Once someone has an accurate model of your face, they may be able to generate new angles, expressions, videos, and virtual appearances that never existed in the original data. They could make the model smile, speak, look angry, or appear inside a completely different environment. So users are not only asking, "Does this look realistic?" They are also asking, "Who controls this version of me?" That may become the most important question in the entire industry. People might be comfortable allowing an app to scan their face for a single purpose. For example, trying on makeup or creating a game character. But will they still be comfortable if the company stores that facial model indefinitely? Can the model be used to train another AI system? Can it be shared with advertising partners? Can it be transferred if the company is acquired? Can the user permanently delete it? What happens if the data is stolen? A password can be changed. Your face cannot. This means 3D facial data has to be treated differently from normal content. It is not just another photo sitting in cloud storage. It can become a reusable digital representation of a person's identity. If companies ignore that difference, better realism may actually reduce trust rather than increase it. The more accurate the model becomes, the more valuable and potentially dangerous it becomes. There is also the issue of consent. Let's say I upload several photographs of myself, and an AI system creates a 3D version of my face. That sounds simple, but what if I upload a photograph containing other people? Can the system reconstruct their faces too? What if someone creates a model of an actor, politician, employee, former partner, or random person on social media without permission? The technical ability to reconstruct a face does not automatically create the ethical right to use it. This is especially important because high-quality 3D reconstruction may eventually require very little input. In the past, building a detailed face model could require special cameras, multiple viewing angles, controlled lighting, or professional scanning equipment. As AI improves, systems may be able to estimate surprisingly detailed geometry from a small number of ordinary images, or even from a short video. That makes the technology easier to use, but it also makes unauthorized reconstruction much easier. So when people talk about the final trust barrier, I do not think the problem is simply the uncanny valley. The uncanny valley is only the visible part of the problem. A face may look perfect and still feel untrustworthy if the viewer does not know whether it is real, generated, authorized, or manipulated. In fact, perfect realism could make the trust problem worse. When synthetic faces were obviously fake, people could identify them quickly. But when reconstructed faces become indistinguishable from real recordings, appearance can no longer function as evidence. We will need other forms of verification. That could include clear labels showing when a face is reconstructed or generated. It could include digital signatures proving where a video came from. It could include consent records attached to a facial model. It could include visible indicators showing whether a person is being represented live or through an AI-controlled avatar. The goal should not be to make synthetic faces less realistic. The goal should be to make their origin more transparent. Because trust does not come from hiding the technology. Trust comes from helping users understand what the technology is doing. I think companies will make a major mistake if they believe users only care about visual quality. Developers may look at a reconstructed face and focus on skin detail, frame consistency, expression accuracy, and rendering speed. Users are asking different questions. Is this person real? Is this happening live? Did they agree to this? Is my facial data stored? Can I delete it? Could someone use it to impersonate me? Those questions are not solved by a higher polygon count or more realistic skin texture. They are solved by product design, security, transparency, and control. For 3D facial reconstruction to cross the final trust barrier, I think users need to feel ownership over their digital face. They should be able to see what data was collected. They should know exactly how the model will be used. They should be able to limit it to a specific application. They should be able to revoke access. And most importantly, deletion should actually mean deletion. A company should not tell users that their face model has been removed while quietly keeping extracted features, training data, backups, or derivative versions. That kind of behavior may provide a short-term business advantage, but it destroys long-term trust. Another important factor is emotional accuracy. A face can be geometrically perfect and still feel emotionally empty. Real communication is not only about moving the correct facial muscles. It is about timing. A smile that appears half a second too early can feel manipulative. Eye contact that never breaks can feel uncomfortable. A digital assistant that continues smiling while delivering bad news can feel disturbing. So the next challenge is not simply reconstructing the face. It is reconstructing believable behavior. And this may be much harder. Humans are inconsistent. We hesitate. We look away. We react differently depending on context. Our expressions are not always clean or predictable. An AI system may try to improve communication by making expressions clearer and more polished, but too much perfection can reduce authenticity. Sometimes the tiny imperfections are what make a person feel real. That means developers may eventually need to decide whether they are building a perfect face or a believable face. Those are not always the same thing. There is also a danger that companies will use trusted-looking digital faces to increase persuasion. A realistic virtual salesperson could adapt its expression based on the customer's reactions. A digital financial advisor could appear confident even when its recommendation is uncertain. A political message could be delivered by a reconstructed face designed to feel familiar and emotionally reassuring. Once facial realism is combined with personalized AI, the system is not just communicating information. It may be optimizing the emotional response of the viewer. That does not automatically make the technology harmful, but it does mean we need boundaries. Users should know when they are interacting with an AI-generated face. They should know when facial expressions are being selected by an algorithm. They should know whether their own reactions are being analyzed in return. Without that transparency, realism can become a tool for manipulation. So, can 3D facial reconstruction finally make digital humans trustworthy? My answer is yes, but only if we stop treating trust as a graphics problem. Better geometry can solve visual inconsistency. Better animation can reduce the uncanny valley. Better lighting can make virtual faces blend naturally into real environments. But none of these things can answer questions about consent, ownership, authenticity, or misuse. The final barrier will not be crossed when digital faces become impossible to distinguish from real faces. It will be crossed when users no longer feel that the technology is hiding something from them. The most trusted systems may not be the ones that create the most realistic faces. They may be the ones that clearly say, this is a reconstructed face. This is how it was created. This is who controls it. This is what it can and cannot be used for. That kind of honesty may sound less impressive than perfect realism, but in the long run, it is much more powerful. Three-dimensional facial reconstruction is bringing us closer to a world where identity can move freely between physical and digital spaces. We may use our digital faces in meetings, games, education, entertainment, healthcare, customer service, and virtual worlds. The technology is coming. The real choice is what kind of relationship we want to build around it. Do we want digital faces that look human but operate like hidden corporate assets? Or do we want digital identities that remain under the control of the people they represent? For me, that is the real final barrier, not whether the face looks real, but whether the person behind the face still has control.